And I would request Ms. Shivanshi Kataria to please present the profile of Dr. Saxena. आवाज नहीं आ रही है?
Sorry, it was mute. Dr. B.K. Saxena has more than 5 decades of experience in shipping and is retired founder principal of Tolani Maritime Institute. He is presently the chairman of Research and Training Committee of Indian National Ship Owners Association. He completed his marine engineering from DMAT, Calcutta in 1968 and sailed on different types of ships for 14 years with 7 of them as chief engineer. Thereafter, he worked in the technical and commercial departments of Shipping Corporation of India in Mumbai for many years before joining the academy. He was the founder principal of Tolani Maritime Institute, which is the largest maritime college in India. He retired in 2018. He completed his 2-year full-time PG from the prestigious World Maritime University, Malmö, Sweden in 1990 and has also taught there in 1991 to 92. He also completed MS from BITS Pilani. He has a diploma in insurance law from Madras University and diploma in financial management from Narsi Munji, Mumbai. He has completed his PhD at the age of 61 from the Symbiosis International University, Pune. He has also completed his post-graduation diploma in international maritime law from WMU, Sweden. He is the Fellow Institute of Marine Engineers and also its past president, Fellow Institute of Engineers, former national chairman and present member of Marine Engineering Division Board, Fellow Narottam Morarji Institute of Shipping, and immediate past chairman of its governing council. Past chairman DMAT Alumni Association, senior member American Society for Quality USA, and he was also a part of team of quality professionals who developed a quality system standards for education in US. Member Executive Council Indian Maritime University Chennai, member Institute of Chartered Shipbrokers London, member Arbitration Council of India, member Academic and Governing Council of Tolani Maritime Institute, member Indian Maritime Foundation.
I think you should have edited it.
Everything
All that is not required.
No, she should
It's
continue.
not required.
She should continue.
Associate Editor of Journal C of the Institution of Engineers, published by Springler. Member of Indian Delegation to the International Maritime Organization, London. He has visited about 70 countries and has worked on assignments in UK, Sweden, Ecuador, Korea, and China and Singapore. He has published and presented papers in many conferences in India and abroad. He is a recipient of Outstanding Contribution to Met Awards by Government of India. He has achieved Lifetime Achievement Awards from Global Met, the International Association of Maritime Institute, Foreign Ship Owners Association, Institute of Marine Engineers, and Mentor for the Year Samudra Manthan Award.
Thank you, Shivanshi. Dr. Saxena, she should proceed with the profile और थोड़ा और ऐड कर लेना चाहिए because participants को पता तो लगे कि किस we are going to listen an authority in shipping industry. So I request now Dr. Saxena to please proceed with this paper. Puneet, PPT.
Can you see my slide, please?
Yeah, it's available.
Okay, thank you, Mr. Rakesh Puri, and greetings everyone from Pune. And Thank you, Shivanshi, for it should have been edited, because it's too long and normally I send this and then I tell the organizers you can pick up whatever you think is really appropriate. But anyway, nevertheless, it's always nice to hear something good about you. So, okay, so thank you so much. And I have a very limited time, so I will not uh, waste any more time, and I'll proceed directly with with my presentation. And if there are questions later, then we can sort of take them up. And I doubt very much if many of you are really uh, aware or know much about maritime sector. It's quite a mysterious and exciting and fascinating opportunity and career. And I'm going to start very briefly with just to show you that what we are talking about, and then we will talk about the IoT part of it actually. So I'm discussing the use of IoT in merchant marine and not related to the defense. Okay, so I'm not part of the Indian Navy, which is really like armed forces. I'm part of the merchant marine, whose job is actually to, something like what you can call a Malgadi equivalent. Okay. So these are some ships. This is a ship which carries, grain or iron ore and all that, maybe 2 lakh tons at a time. This is a big oil tanker carrying oil, you know, 2.5 lakh tons. Here you have LNG carrier, gas carriers, and it's very interesting. These two photographs are on regarding car carriers. India exports a lot of cars, and such ships come to Mumbai and Chennai, and at one time they can load almost 5,000 cars. You see different decks are there where cars are located, and this is how the cars go in and come out. Uh, then these are the container ships. I'm sure you have seen containers on the road, on the trucks. And at any time, such ships carry about 22,000 of them. Unbelievable. 22,000 such boxes on one ship. The cost of cargo itself is more than $1 billion. Billion. 1 billion is 1,000 million actually. Then these are the ships, which are cruise ships, holidays, nice swimming pool and lots of people. But on cargo ships, you normally have only 20, 22 people. It's always not very nice, sometimes very nasty, many times nasty. You see the weather like this, things can be very, very difficult. And you have, the right-hand photograph where you see the ship is in the frozen sea. The sea is frozen. It's going through the ice. Okay, let's get back to the serious talk. Okay. So, uh, IoT is used substantially in marine sector. I've just chosen some of the areas. One very important thing is the navigation. Okay, because the
Uh,
uh, ships do need
uh,
to navigate. Ships do need to navigate, and it's not like a road where you can see where you're going, like in the sky, and same in the sea. It's a water, water, water every year, everywhere, even hundreds of miles all over. There are no markings, no nothing. So you need to navigate rightly so that you reach the place where you are destined to reach. And the communication. So normally this navigation and communications are treated together. Yeah. Now from the navigation, we have systems, for example, regarding, you know, for the decision making, course change and all that. Then collision avoidance. Collision is one of the major issues at sea. Collision should not happen. Machinery related issues, positioning of the ship. Because what happens when a ship is going in this direction, it's on autopilot. It's not that somebody is holding the steering. Okay. When the vessel comes to when the ship comes to inside the port, then somebody is steering. But otherwise, it's on autopilot. Now, when it is on autopilot, then the vessel is at the mercy of the waves and the winds, and therefore it cannot keep the straight course. So with the result, what happens as soon as the position is noted that the ship is, off course by a certain degrees, immediately it has to be brought back. So that's why there is a constant communication with satellites. Okay, things have become much simpler today. Earlier, when these were not there, then through the sextants. I don't know if you've seen in the physics laboratory and all. We used to use the stars and sun and moon to find the position of the ships. Today it's all setcom and set navigate, set nav, setcom. Okay. So similarly, regarding the communication part, uh, today people have to be in touch with each other all the time. When I was sailing, which was very long time back, things were very difficult, very very difficult. Okay. I remember my wife's father passed away in Lucknow, and we came to know after 4 days. 4 days. That is the kind of communication that time. Today it is not like that. Okay. Then between the ship and various other, so one part is related to navigation part. One part is related to the communication part. With the port, when we say communication with the port, communication with the head office, communication with the government agencies, all this are through satellite using IoT mechanisms. Okay. Then the other thing is, see, a ship is like a factory, like a floating factory. You have the main propulsion engine, which could be, as much as 30,000, 40,000 horsepower engine, which is the main propulsion, which is moving the vessel. And you have three or four more diesel engines producing electricity. So you have the power system, power distribution system, air conditioning system, whole lot of different systems. Okay, so one system. This is purely this slide is regarding the performance monitoring and maintenance, because performance of the engines have to be monitored very well. Because it's not like if something goes wrong, you can go to the garage because there's nobody to help. It has to be done on the ship in mid-ocean. Okay. So therefore, it is very important that uh, online monitoring is going on. All the time monitoring is going on, so that if something goes wrong or something is about to go wrong, those signals are sent, and so that corrective measures are taken immediately rather than having a breakdown maintenance. Although that also sometimes happens, but by and large, most of the maintenance has to be uh, preventive measure, maintenance and condition monitoring. Okay. Then the safety is very important, you see, sir, because in the ship, one of the major concern is fire. Because if the fire happens, there's no fire brigade there. The water, so much of water, but there's no fire brigade. Fire has to be fought with the crew. And today, especially these container boxes carry all kinds of dangerous cargoes. So the fire can be very, very nasty. All the safety related ones. I showed you a photograph of a LNG ship. It's like a floating bomb. You see, you're carrying almost about 70,000 cubic meters of natural gas. If something goes wrong, you just had it. So the safety mechanism, collision uh, avoidance, then propulsion, electrical, then maintenance part, and voyage planning with weather routing. Because sometimes, you see, I'm sure when you fly in the plane, you would have noticed that sometimes there is a little bit of bad weather and all, but it's only for a few minutes. But here it can last for days together, and therefore corrective measures have to be taken much earlier so that the correction in the route can be done. All that is again through the IoT mechanisms. Okay. Then one other very interesting thing is, which is really fascinating, and that's where the IoT has been used extensively, is the container tracking. I told you today, millions of containers, those boxes are going around the world, on the ships, on the road, on the train. Okay. and you can see it on the food malls, and you can see them everywhere on trucks. Today, as a customer, if my cargo is going somewhere, I want to know where it is. I want to know where exactly it is. And today that is possible through the IoT of things. Okay, today it is really possible, and there is a huge market for this, huge mechanism of it with RFID. Each container is all the time identified. So when it is in the port, when it is in any container terminal, when it is at toll plaza, or when it is on the railways, immediately the inputs come into the system, and similarly output goes to different parties, to the customers, to the shipping companies, to the ports, the government, customs, other operators, logistics, supply chain. So this is one very big mechanism which is going on, and India is one of the premier country which is doing it for all over the world, not only the Indian. I mean, shipping is international. So we cannot talk about our one country actually. So this container tracking again uses through satellites, uses all different kind of mechanism between the seller of the cargo, between the receiver of the cargo, and through all the mechanisms, and whether it is on the container, is on the ship, on the truck, on the road, or it is in some storage. It has to be known on real-time basis where exactly the container is. Then the IoT is also used in training substantially. This is the engine room machinery training. This is the navigation training, and here you use real simulators where all kinds of weathers can be simulated. So you can really feel that the ship is moving like this. The storm can come in, the fog can come in, the rains can be brought in, and this is used for the trading. Okay. One major problem today is, as I'm sure you all are aware of, is the cyber threat. This is one of the major issues in shipping, like in everywhere else. I'm sure you would have seen the containers which are blue containers, Maersk written there. Maersk is the world's largest shipping company from Denmark, Copenhagen. They lost $3.6 million in a cyber crime. $3.6 million they lost it. So today that is a big problem, and I can give you only two examples. There are so many here. One is this AIS. AIS is automatic identification system. Every ship has got a certain mechanism by which it sends signal, and the port can, or anybody can monitor which ship it is, from where it is coming, from where it is going. Now, this can be hijacked, or this has been done. With the result today, what can happen that there is a ship, but you don't know where it is from. And now you can understand that how this can be used for the terrorist purposes, for smuggling purposes, for all kinds of nonsense. There's another one is this EGDIS. You see, you have the navigation charts. Earlier, they were all paper charts in which you plotted where you are and all. Today, it's all electronic. And they're connected through IoT from the shore. Okay. It is not very easy, but it is possible that a signal can be sent there, and therefore, on the chart, suddenly the signal shows that there is some obstruction outside, whereas actually it is not. So instead of going like this, you go like this and then land into trouble. Okay. So these are the kind of threats which are happening. Okay. A lot of work is going on this. The digital twins have been created so that you can have better understanding, better clarity of how to process, and so that experimentation is very expensive today. You can't do that. Okay. So this makes things comparatively easier. And I'm sure you have already heard that there are, cars and buses without drivers and all that. Today we have ships without a crew member, not even a single crew member. Of course, it's called autonomous ship. This is the first one, small one, in Norway, but this is possible today. So that means totally controlled from shore, totally, completely controlled from shore. Not even a single crew member on the ship. An ocean-going ship, not a chota ship, and not a coastal ship or something. Okay, so in the limited time, I have tried to sort of give you a picture. I'm sorry if I have rushed through and I've sort of avoided giving more details, but at least I'm sure you got a glimpse of it. I once again thank the organizers for giving me this opportunity to talk with you all, and I'm sure if there are any questions, we will take them up as per the program. Thank you, gentlemen, ladies.
Thank you, Dr. Saxena, for your wonderful presentation on IoT in marine. The question answer session will be taken here at the end. So I request you to please stay with us. Now, before we continue, I have just an announcement to be made. IoT Society of India is in the process of opening two more chapters, one at Noida, Delhi NCR, and another at Prayagraj, Allahabad. We have already got a chapter at Lucknow. So whosoever is interested in joining IoT Society of India in the capacity of an executive committee, management committee, office bearers, they are requested just to send a mail. Mail address is already in my notification, IoT Society of India 1 at gmail.com. Just they send me a message that I want to be associated with IoT Society of India, and just send it to me, and I will revert and for further processing. Now, I think Dr. Lakshman Singh. Now I request Ms. Shivanshi Kataria to please present the profile of Dr. Lakshman.
Thank you. Dr. Lakshman Singh is a technocrat, economist, and a project manager with over 20 years of extensive experience leading and managing avionics project at Hindustan Aeronautics Limited, a DPSU of Ministry of Defense, Government of India. Recognized as technical leader by various agencies in USA, Australia, Spain, and India. He has received accolades from his exceptional technical and program leadership in the aerospace sector. His academic prowess spans around science, engineering, and management and economics at both undergraduate and postgraduate level. Dr. Singh has achieved significant milestones in multidisciplinary research and demonstrated leadership in a wide range of transfer of technology initiatives, contributing significantly to Make in India campaign. His comprehensive expertise is invaluable to the entire technologist community. Dr. Singh is qualified independent director from the Ministry of Corporate Affairs in conjunction with Indian Institute of Corporate Affairs, Government of India, holding the position of independent director at Aerocraft Private Limited, Noida, with a strong performance record in project and operation management, professional exchange, strategic planning, administration, financial management, human resource development within the aerospace sector. Dr. Singh brings a cohesive vision for a sustainable economic development and social welfare. With this background, he is eager to engage with academia by offering his insights and expertise through participation in international conferences, whether it be contributory talks, keynotes, invited talks, or serving as a conference chair from industry side. Further to that contribution in different committees of academia, Doctoral Board, Industry Institution Interaction Committee, R&D Committee, Advisory Committee, etc. from the industry side will fill the gap between academic and industry and commercialization of academic findings. He believes his experience and dedication to advancing knowledge in the field make him a suitable candidate for such role. He looks forward to the opportunity to contribute to the academic community in meaningful ways.
Thank you, Shivanshi. I request now Dr. Lakshman Singh to please proceed this talk.
Very good evening and Jai Hind from myself. I hope I'm audible to all of you and
Yeah.
my slides are visible to all of you. Thank you very much for great introduction of me, and thank you very much to giving the platform where I can able to share something about the IoT and defense application. Yes, in the before going to start of this topic, let me introduce some basic point of view that as a divisional chairman of IoT Society of India Defense Chapter 11 at Lucknow, the society 15 September 2023 as a registered society of non-government in UP, and this registration number it work in the field of information communication science technology vocational training and skill development in the UP. Location is nearby the Lucknow Indanagar, and our police sir is holding this society as a for the welfare of science and technology. So before going to this slides, I already everything is introduced. It is only the for information that yes, I am working with Hindustan Aeronautics Limited and joined this society on my personal capacity with the permission of my organization. So yes, it is a defense organization, so a lot of things are hidden to common people. And with this limitation, I would like to brief something so which you people came to know what is the avionics in defense and how IoT can influence this technology area and what is the policy making we can go ahead. So before going to this topic, let me say about what is avionics. Just Dr. Saxena sir has mentioned the some with photograph. So I'd like to say I took only four example. If we say avionics, it is nothing but the semiconductor electronics with optics, and it is engaged in the use of the aircraft which fly in the air, and when it's come in the defense, that means it is a military airworthiness. So in the navigation systems, yes, it is a common which we use in the mobile in the our car, but it came in the aerospace, so there is a lot of military airworthiness qualification requirements happen. So this is the one of the avionics which we are using in the aircraft. Some in the cockpit, if you say in the commercial cockpit, the same thing is also in the fighter aircraft cockpit, but it is very compact. So here we are using the multifunction displays, we are using the head up display, we are using the helmet mount display. It is a for fighter aircraft. So if you see helmet head up display, it is nothing but in the cockpit and the fighter aircraft it had be to show the main information when pilot seeing the upfronting of the head of his head. And HMDS is nothing but it is mounted in his helmet itself. So with the movement of his head, he able to see any target. So why I'm saying these things, because here is the IoT is involved. With the recorder system, yes, it is nothing but to record all information of the health of the aircraft in the as a accidental investigation point of view, which we called in a normal language black box, but actually it is a orange block because it is a visible in the of visible wavelength. It is, can be seen from the far also, and some of the optical and laser systems which is used for the weapon point of view. So mainly IoT can be utilized in the HMDs, in the HUD, and as a display system. How it can be utilized, I will brief something on this topic. So if you see the industry pattern point of view, it is a very basic. I will not go in the detail, but yes, to start on the topic as a policy, I would like to say industry 1.0 is nothing but when we are using the mechanical production system moving. Then we switch to industry 2.0 when we increase the mass production, when we use electricity. And industry 3.0, it is long term, it is what long distance we traveled where we ICT, electronics, semiconductor, nano electronics, we came in the picture. But industry 4.0, where everything is came in the data, machine learning, everything come in the virtual field. So everything is come in very drastic change. So I'm very fortunate that I'm the man who see from 2.0 to 3 and 3 to 4. So maybe 4.5.0 industry will come. So in the industry 4.0, there is IoT applications came and is a ninth pillar. So previously our factories was normally in the capsule arrangement where we produce, and chain arrangement supply chain is there, but now our all information, data package, our document, everything come in the cloud point of view. Being a defense industry, I could say that uh, we cannot post all our information to the cloud because it is for safety point of view and cyber security point of view also. But anyhow, the locally we manage our things in a such a way that it should become in our network itself, which is defined by the government of India also. So we use such type of thing, but it is very limited use. It is not expanded fully in right now in the defense domain. But yes, it is enhancing, and future it will come. How it will come, I would like to say on this topic. I'm not going the technical. Where is the scope? Where is the IoT application in defense avionics, and how advanced IoT enabled avionics technology came? If you see the smart aircraft systems where we can real-time data monitoring. Yes, Dr. Saxena sir has mentioned like that, because whatever the data we collect with the flying of the aircraft, we transfer this information to the ground station, the real-time basis, where we read everything and we are able to detect any prognostic and any predictive maintenance point of view also. Enhanced navigation communication, yes, with the real-time data we can actually give the actual information to the aircraft for their navigation, as well in the case of war point also. In the flight data recorder, yes, we faster and more accurate incidents analysis we can do if you use the IoT enabled SSFDR, which is right now it is not there for as well as the foreign as well as the Indian SSFDR. It is We are using the predictive maintenance and condition monitoring for the IoT applications. We are using sensors. We are applying the sensor in our factory area machines, in our vibration area. So we have to check because our machines are run not for 8 hours or 10 hours. It run continuously for 10 days to 15 days, like that. So people cannot stand in front of the machine to see which is running or not. So we put the sensors and we collect the data in the central computer and we see its health. So like that we are using the IoT enabled sensors, and the common networking point of view use it. And yes, it is cost efficient also, because for this we have to engage the cameras and manpower. So by IoT enabled sensor we manage it. And yes, autonomous systems and the UAVs point of view, because UAV is the unmanned air vehicle. So here what we use, we directly real time transmit the data on the ground station. We collect it accordingly. We make a war plan. So one UAV goes only to fly in the air. He see everything. It is you can say counter information, electronic warfare. He collect every data. He transmit to ground station, and accordingly the second UAV goes with this enabled information to war. So if you see the sometime enemies or sometime our in the war position, some UVs flow only to fly to collect the data. This collection of the data engage another UAV to drop the bomb, to drop the missile, like that. So here we are using IoT from the ground support. And cybersecurity and data integrity, yes, that is a chapter of the challenge for us, because in this field, defense applications, we can say we are weak. We are not zero, but we are weak. Still we have to go long distance. Smart cockpit, it is coming, where all avionics display are interconnected in such a way whatever the important information is, it has to be come in front of the pilot. He has to take decision immediately in the war conditions. Augmented HUD is now coming the picture, which is normally we are using in the video games and in our entertainment point of view, but now it is also coming for the defense application. Yes, ground stations also IoT enabled. Electro optic systems, yes, for the surveillance point of view, we are using the electronic pod to collect the data, their territory informations, because right now the war is not by your power, by your guts and by your technology. Some now war is for data. How much data you have of your enemy, how much information you have. Accordingly we have to plan our war, we have to plan our strategy. It is a winning. So the now scenario is changing. So the data and the IoT application, the AI application is going on in the developed country, and we are also proceeding toward this line. So this is the for the aircraft point of view, but now the factory, the logistics, it also use the IoT application. Normally, previously we use the supply chain arrangement and logistic in a common way, but now it is a smart inventory management we are doing. That means whenever our item is good in the stockpiling, there is obsolescence. If we feel there is a stock is required because it is come in the critical path, so alert is automatically come through our ERP system. Yes, your stock is going to decrease and will finish in coming 1 month or 2 months. Accordingly, we plan it and we make a purchasing order. So these IoT applications we are engaging in our enterprise resource planning on our system itself, where we purchase a lot of things. And this purchase is not for the dollar, $1 or $2. It goes in the million and billion US dollar purchasing. So this is the IoT application we are using it with the manual interference and with the IoT output we combine together and we do the purchasing. If you see the production setup, yes, right now we are in the 3D printing and CNC machines, IoT sensor, we are using the health monitoring of the machines also, and quality inspection we are using it. Yes, it is a very initial stage, but we are proceeding and some good output we are received here. And IoT factory setup, if you say right now, whatever the new factory is going to set up in the defense domain, it fully engage with the IoT applications, data, machines, and everything is a data point of view. So yes, which are factories already established, there we are engaging the IoT. But which factory we are going to open new, we are we are using the IoT as a industry 4.0 and yes, industry 5.0 also. There is a challenges, yes, because there is a lot of news came in the internet and website and news channels that there is a data cyber security risk and interpolative risk and data overload. So because our enemies are there who always open their eyes to catch the data, so there is some challenges, yes, but it can be met by the cyber security risk management and the encryption descriptions ideas and regular monitoring of these things. So these things are in the I'm putting here in the challenge and consideration. But there's a government policies also. If you see, I will not elaborate this detail, but it is mentioned the chapter wise and para wise, where government of India has mentioned the IoT in our defense procurement, in our defense policies. If you see the defense production export promotion policy, they mention the IoT adaptation in manufacturing of avionics. In Digital India itself, it is already in the IoT and AI. In cyber security is mentioned. And then national cyber security policy is all of this document which is drafted by the this present government, they impose, they says as a policy formation the IoT. But if I come in the defense specific to the avionics, then there's a DAP 2020 which is released recently, and this amendment is supposed to become in 2025. Here in the chapter wise, the government of India has mentioned as a policy to application of the IoT, adaptation of the IoT. So if you see DAP 2020 in the chapter 30, page number 37, they specifically mentioned encourage to IoT based smart manufacturing. So these are the policy which is already incorporated by the government of India, and we are using it. So the mandate is available. Only there is some skill gap, there is some understanding gap, but it is speedily going to fill. And we are using with this policy point, we are using this, and we are engaging our industry, our factory, our people, everything to be enabled by the IoT. So these are the points. But where is the existing case right now which is already enabled after the it is a case of 5 to 6 year only, it is not late. uh, Everything is in the IoT. When the defense application it came after 2020 only. So some of the example I put here in front of you. If you see the HL itself, we are using IoT enable avionics for the health monitoring of the aircraft, so that we can make the predictive maintenance of the aircraft, and we can reduce the ground time of the aircraft, we can reduce the aircraft on ground and maintain the high fleet serviceability. Same in the Bell is also using the IoT based border surveillance system, because Bell has the good in the field of army supply. So their equipment is available in the border forces, so they are using. If you see the cost in investment by this company, it is a tentative cost. I cannot say the specific value, so that's why I put in the tentative cost and timing. And the reference is available in the website also, you can find it. So this approximately, if you see how whole summary, it is a good amount. DRDO and Indian Navy, Right now, the Tata Advanced Systems is coming in the very good picture as a platform integrator for the defense applications. Here, they are also using the IoT enabled ground control system, UAV operations. L&T is also coming. Idea Ford, Scient, and these are the private companies who are coming. Right now, we came to know one news: Solar Industry India Limited, where our Prime Minister, respected Prime Minister, visited, and he has inaugurated his UAV runway. So his whole setup is a IoT based, and everything is a AI and machine and data based setup is there. Facilities fully. Yes, I have read everything on the literature of the internet and the news channel itself. But yes, my wish, I will visit this place and see how these are set up. So because of this, government of India is came and they make some inauguration in this field. So these are the some example I'm putting. Now, what is our role? Because as a chairman of the IoT Society of India for the defense chapter, how we can engage this IoT application in the defense field. So with this, we can play the strategic role, technical expertise, whatever the our group is available, they can use it. The policy recommendations, because the government of India makes the policy at the very top level. If you see, execution of the policy is not mentioned anywhere, because as an individual capacity, the project manager, as an individual capacity of company, sometimes they didn't know how to implement this policy in our factory and in our production or our unix. So here we can play the role, we can make them easy to understand, and we can come as a good IoT implementer in the India. So how we can go, I have some plan, that's why I put here. It is my top level understandings. I cannot say the macro work down back structure, but yes, some opportunities available to our society where we can do the consultancy and industry collaborations, where we can use IoT applications to their defense production and manufacturing setup. And their, we can take our one example, they say IoT technology assessments. Yes, it is a very good chapter. Sometimes company want to make a tender, so somebody can assess my company how much IoT is required or available IoT application is at the level or not. So we can come as a picture to assess their IoT technology assessment. What is the gap? Where gap have to fill? We can recommend something as a consultants. Cyber security, yes. Smart factory, when factory is going to establish, with there we can engage ourselves to give some inputs. There we can be valued also. And defense IoT R&D collaborations. A lot of R&D centers, universities, IITs are there. We can collaborate to learn ourselves also. Accordingly, we can use this to migrate to commercialize to industry application. Yes, training skill and development is a common point for everybody, but yes, IoT based training skills is required to our industries people also. And we can, yes, also come in the policy formation. If we are mature enough and government recognized us with this activity, we can derive our policy also, which can come in the picture after some time in the IoT application in the defense field. So these are the points which I had mentioned here with some of the finding, some of the understanding. And thank you very much. I would not like going to take the more time, but yes, this is my submission to all of you. I have briefed some avionics, briefed some IoT applications, and our IoT Society of India how can enter in this field. Thank you very much to giving the opportunity, because time is important. So I have to finish this presentation within half an hour. So hope, Puri sir, I have completed in the good time frame, and we are open to myself along with Dr. Saxena sir to questions, to answers, anything else.
Thank you, Dr. Lakshman Singh. Now, webinar is open for question answer session. Anybody wants to ask a question, they can proceed. First thing, I just want Dr. Saxena, I don't know वो हमारी field का question है. Communication must be a big problem because satellite communication is not that fast, and IoT require a very fast communication. So how deal with that problem?
Okay. Yeah, thank you. Thank you. I hope you can hear me.
Yes, sir. Yes, sir.
Yeah. No, today it's very fast. The communication is very, very fast because the satellites which are being used, none of them is the Indian satellites. They are usually the American satellites, and absolutely, real-time transfer of data, and even the voice happens. So today that is not really a problem. No, negative, negative. The only worry is always there that if the satellite doesn't work, then what will happen?
Yeah.
That worry is there. That's why in the training, people are still taught to the basics. Especially regarding the navigation and communication, of course, through this EGDIS, what we call, Morse code, using the lights and flags and all that. That is still taught. Yeah. Uh,
Thank
I,
you.
I I saw one question related to weather routing on the chat. Somebody had asked about weather routing.
If the person is available, you can ask the question.
Yeah, I think there's a gentleman who had asked, Mr. Akshit Thakur.
Thakur is available.
Hello.
Ah,
Good evening, sir.
Good evening.
really.
So, yes, sir. My question is regarding, sir, in maritime, in case of bad weather, that how can IoT play role in finding the best route possible to avoid some bad weathers in maritime? Is it possible? And if yes, then how it can be done?
Yeah, it is possible, and in fact, that technology was improved, but it's quite old actually. It's been there for decades together. I mean, at least for 3 decades. There are weather routing companies. There are international weather routing companies who do this for a charge. It's not free. The service, you have to pay for it, and the ship has to tell them that I'm going to go from here to there, and these are the peculiarities of my ship, because every ship is different. You see, okay. In aircraft industry, you still have certain standardization, especially in the passenger. You have Boeing, you have Airbus, and all that. But in shipping, it's all very, very different. So every ship, the size is different, the speed is different, the structure is different. So that has to be told to them, and then they will say, okay, this is the route you have to take, and then you follow. Now, how do they do this? Is, they have the transponders, in different locations. With that, the various meteorological organizations provide feed so that they know that this is the area where, a typhoon is coming, or the bad weather is developing, or a cyclone is coming. Okay. So with that, they will tell the master, the captain of the ship, that this is the route you are supposed to take. Okay. But the captain's discretion is always the final one. So he can make a change if required. But it is possible, yes. Hmm.
हेलो सर।
Yes, please.
हाँ सर, मेरा नाम अमित कुमार गुप्ता है। आज सर एक क्वेश्चन से ये था कि सर जैसे होता है कि हम पेट्रोकेमिकल सामान लेके जाते हैं या ट्रेवल कर रहे होते हैं, जिसमें हमारा मटेरियल सामान जाता है शिप्स कार्गो के, तो कभी कभी होता है कि समुद्री लूट उन पे अटैक कर देते हैं। तो क्या हम ऐसा उससे रूट डिफाइन करके सेव कर सकते हैं आईओटी को यूज करके, कि प्री डिफाइन हो जाए कि हाँ भाई इस जगह पे ऐसा होने वाला है, या सम केसेस कि जो कुछ सेंसर्स लगे होते हैं अंडरग्राउंड वाटर में डाल के उनकी आइडेंटिफाई, उनकी स्पीड्स के बारे में पता कर सके करने के लिए।
Yeah, actually, the drone issue is a big problem today. It's by Houthis, by these Houthis near Yemen. Unfortunately, the area they are operating is one of the major sea lanes. Because if you revisit your geography, coming from USA and Europe to India or going to Japan, one method is via the Suez Canal, and a longer method is going around the Africa. So obviously the longer route is more expensive. Okay. So with the result, the only route is via Suez Canal, and when you come via Suez Canal down the Red Sea, there's no way you can avoid this. There's no way you can avoid. Uh, there are certain companies, especially those uh, who are in the container business, some of them have chosen to go round, but eventually the cost increases. Eventually, the customer has to pay more. Okay. Fortunately, so far, they have not attacked too many of these oil or chemical ships. Because they also understand, that the repercussions can be tremendous. So a whole lot of ships are passing, but it's it's not it's not a very serious problem. It is a problem, and because of that, the insurance industry is blooming, and the insurance premiums have gone up and all that. But it's like this, that you cannot avoid the route. However, certain areas, like piracy has been one of the major problems in last again 10, 12 years in near Somalia, in the Eastern Africa, southern part of the Eastern Africa. So that you can avoid, that you go a little longer route. That is possible. But this the drone issue is really nothing much can be done. And same like the problem between Ukraine and Russia. I mean, see, Ukraine is one of the major grain supplier to the world. So the ships are still going in. And the war is happening, but the ships are still going, loading grain and coming. So the work goes on. So, but
Dr.
you
Saxena,
can't really avoid it. Yes, yes,
Dr.
please,
Saxena, sir, I can answer some more
please,
because
please,
what you have explained is good because it is
please.
somehow it is related to also. Sir, one answer you have given is correct. This is the risk which we are taking. Sometime we have to proceed with some risk. So this is the one risk. We have to be with this risk and it cannot be avoided. But yes, with this some solution is coming. If you see the present news is there, the one company in the from Mumbai, Paras Defense. Paras Defense get the order for the anti-drone system, which is the high beam laser energy. So they receive right now the order from Government of India. They are going to develop it. It will take some time, but solution is available. It is not with us, but some people are using. It is not mature in any country right now. So what is available in the ship will be mounted laser gun, and it always have a one radar who will see in the surrounding area what the drone are coming. If drone there is some coding, something is there. If drone is enemy, fire the high beam laser energy to destroy the drone. So this is a one solution is suppose I assume that it will come in a mature stage after 5 to 10 years. Saxena sir, that I am putting in front of you with your kind permission, sir.
No, thank you, thank you. I think that's good. That's good. But as of now, the problem is there. I mean, we keep on following the ships which are hit, but they are also very sensitively using that. They are not trying to sink any ship. So far, except one ship, no ship has gone down.
Yes sir,
Okay,
yes sir,
so they
yes
are
sir,
very selective in this. They're
yes
just
sir,
creating nuisance. That's all.
yes sir, correct sir.
Yes, anybody else?
There was one question on the
यस सर एक
autonomous ship. Yeah, please, please.
सर एक क्वेश्चन ये था कि जैसे हमारा एयर डिफेंस सिस्टम काम करता है जैसे आर्मी में होते हैं तो प्रॉब्लम्स क्या आती है कि जैसे हम उनको सिग्नल जनरेट करते हैं अपने ट्रैफिक कंट्रोल ऑफिस से तो अगर हम जैसे आईओटी को यूज करते हैं और वहाँ पे मान लिया उनके जो हमारे सेंसर्स हैं डिस्टेंस सेंसर्स हैं टेम्परेचर्स हैं अगर बाई चांस उसको हम एक्सेस कर लेते हैं या हैक कर लेते हैं साइबर सिक्योरिटी पार्ट पे ठीक है तो उनको हम अगर मान लिया हमें कि
करेक्ट,
एक्सेस कर लेते
ये
हैं
काम
करने के
शुरू
तो
हो
उस केस
चुका
में
है।
हम
ये आप जो काम कह रहे हैं ये काम शुरू हो चुका है। इट इज़ वेरी बहुत अर्ली स्टेज में है R&D के, बिकॉज
जी सर
सब कुछ डेटा के ऊपर है तो सेंसर बेस किया जा रहा है। नॉर्मली इसमें जो अभी सोल्यूशन अवेलेबल है जो ऑलरेडी
What happened?
जो R&D के स्टेज में है तो दे आर एन यूएस और चाइना और रशिया, इनके पास ये टेक्नोलॉजी है जिसको वो डेवलप कर रहे हैं। तो मैंने कहा ना कि 5 से 10 साल के बीच आपके पास कोई सोल्यूशन दिखाई देगा जिसमें कि हर एक शिप के ऊपर एक एंटी ड्रोन मशीन या एक सिस्टम लगा होगा जो सेव करेगा। थोड़ा दूर है अभी अपने एक्चुअल परफॉर्मेंस से, तो अभी बहुत ज़्यादा मैं कुछ कह नहीं सकता इस पे कि कुछ क्रेडेंशियल या कुछ बातें, बट यस लोग सोचने लगे जब ये कोविड का आया, फिर जो हूती के हमले हुए, फिर इस पे हुए, तो नॉर्मल इंडस्ट्रीज इस पे काम करना शुरू कर रही है।
राइट।
बट सर हमारा जो अपना सिस्टम है सर, अगर हम बात करते हैं बॉर्डर लाइन पे पीओ के अदर्स में, तो वहाँ पे हमारे क्या कहते हैं ऑटो सेंसर डिवाइस और लेजर गाइडेड मिसाइल्स ऑलरेडी लगी हुई हैं, जो इन चीज़ को
5
सेंस
मिनट बाद।
करते हैं। जैसे बॉर्डर ये पे क्या है, हीट सेंसर्स लगे हुए, वो ऑर्डर में इनको सेंस करते हैं, डिटेक्ट करते हैं और लेजर बीम पे जनरेट करके उनको डिस्ट्रॉय कर देते हैं।
बिल्कुल, आप
लेकिन
सही
सर
कह रहे हैं, लेकिन आप ऐसा ना सोचिए कि जो हम सेंस कर रहे हैं वो सब कुछ सही होता है। इनमी
यस सर।
इनमी भी हमें काउंटर करने के लिए फॉल्स अलार्मिंग भी करता है।
ओके
तो
सर।
बहुत चेक एंड बैलेंस है। जो चीज हम सोचते हैं बिल्कुल वैसा होता नहीं है, बिकॉज इन भी हमारा अपोजिशन है, वो भी स्ट्रांग होता रहता है, तो वो क्या करता है, फॉल्स सिग्नल्स भेजता है और हम उससे मिसगाइड भी हो जाते हैं। तो कई बार सेंसर्स के डेटा पे बहुत बिलीव करना आपको आपके लिए हानिकारक भी है, बिकॉज इन्वायरमेंट में डिफरेंट टाइप के फॉल्स अलार्मिंग होगी, आपके हीट टारगेट देंगे, आपको लेजर फायर करेंगे ताकि आप डिस्ट्रैक्ट हो जाओ, और फिर आपके जो टेररिस्ट है वो कहीं और से निकल आते हैं या फिर कहीं से और से हमला हो जाता है। तो कई बार फुल्ली अगर आप आईओटी फुल्ली सेंसर पे बेस हो जाएंगे तो ये भी एक नुकसान है, क्योंकि काउंटर मेजर होते रहते हैं। हम भी यही करते हैं, हम भी बॉर्डर पे होते हैं तो हम कहीं जगह से फॉल्स अलार्म दे रहते हैं ताकि एनिमी सोचे कि हम यहाँ कहीं पर है, लेकिन हम कहीं काम कहीं और कर रहे होते हैं। जैसा आपके पास एग्जाम्पल है, जो हमारा पोखरण का परीक्षण हुआ था, हम फॉल्स अलार्म अमेरिका
यस सर।
हम कश्मीर में दे रहे थे। सब कोई सैटेलाइट से डेटा वहां देख रहा है, पूरी दुनिया कश्मीर को देख रही थी, बट हम काम कहाँ कर रहे थे, कहीं और। तो हमारी तरह दूसरे लोग भी बहुत स्मार्ट हैं। अब चीजें हैं, तो आप जो कह रहे हैं बिल्कुल सही है, बट फुल डिपेंडेंसी ऑन मशीन, आईओटी सेंसर, ये हमें कई बार मतलब 50-50 चांस है, हमें मिसगाइड भी करती है।
एनीबडी एल्स? आई थिंक चैट बॉक्स में किसी ने क्वेश्चन दिया है। द पर्सन इज प्रेजेंट हियर, यू कैन आस्क द क्वेश्चन।
There's a question on autonomous ship or something. I saw.
Somebody asked question on autonomous ship.
Ship without crew member
सर
and all
मेरे लिए
that.
क्वेश्चन है, लेकिन अगर वो मिस्टर शूदन साहब अगर हैं तो मैं बोल सकता हूँ इसके ऊपर। तो सवाल उनका बिल्कुल सही, जो इस समय न्यूज में आ रहा है उसी के ऊपर है। और एक और सवाल उन्होंने ही पूछा, व्हेन कैन वी एक्सपेक्ट द नेक्स्ट फाइटर जेट फ्रॉम एचएल तेजस। तो दैट क्वेश्चन अक्सर हम लोग से पूछा जाता है। इस फोरम के थ्रू मैं आपको एक बताता हूँ, आपको शायद आप इस बात को प्रोपेगेट करें। एचएल एक मैन्युफैक्चरिंग कंपनी है, हमारे पास आर&डी का मैंडेट नहीं है। अगर आप देखिए गवर्नमेंट के फंड्स अलग अलग जगहों पर अलग अलग सब्जेक्ट के लिए जाते हैं। आर&डी इज अ जॉब फॉर डीआरडीओ। उनकी एजेंसीज रिसर्च करती हैं, जब उनका रिसर्च प्रूव होता है तो उस प्रूवन रिसर्च को हम मैन्युफैक्चर करते हैं उनके हिसाब से। सो बिकॉज वी आर द लास्ट फेज, वी आर द एग्जीक्यूटर, सो एवरीबॉडी थिंक दैट वी आर द डिजाइनर ऑफ तेजस। हम उसके डिजाइन में बहुत छोटा हिस्सा है, जो भी हम एज ए मैन्युफैक्चर सपोर्ट कर सकते हैं। तो ये एक मिसरिप्रेजेंटेशन है कि जो डिले है, जो जहाज नहीं बन रहा है, इट इज बिकॉज ऑफ एचएल। इट इज नॉट लाइक दैट। मैं एक स्पोक पर्सन नहीं हूँ एचएल का, इसलिए उस बिहाफ पे बात नहीं कर रहा हूँ, बट वेरी बैलेंस है। भारत सरकार हर एक काम को मेटिकुलसली अलग अलग जोन पे करती है। वो एक ही एजेंसी को आर&डी, मैन्युफैक्चरिंग सब कुछ नहीं दे सकती, अदरवाइज सिस्टम कोलैप्स हो जाएगा। तो आर&डी करने के लिए, सोचने के लिए, उसको बनाने के लिए हम लोग हैं। तो जो आपका जहाज की बात है, इट इज द कॉल ऑफ, यस वी आर आल्सो कम इन द पिक्चर ऑफ डिजाइन, वी आर वर्किंग ऑन दिस, बट mandate is with DRDO, mandate is with DARE, with ADA, with all DRDO agency. They take their sweet time, they develop in 20 to 30 years, 25 years, then it come in the manufacturing, so it is delay. So yes, LCA was in the 1990 या 1988 की बात है, it come, so design ने itself बहुत 20 साल समय लिया, और हमारी डिमांड भी चेंज होती रही। कई बार ऐसा होता है कि जब हम बाहर से हमेशा सामान लेते रहते हैं, फॉरेन कंट्री सामान लेते रहते हैं, तो हम बायस हो जाते हैं वैसी टेक्नोलॉजी को अपने यहाँ लेने के लिए। बट आप समझिए, हमें लड़ाई लड़नी है अपने पड़ोसियों से, या कि अमेरिका में या जापान में या इंटर कॉन्टिनेंटल वॉर नहीं लड़ना हमको। अगर हम अपनी टेक्नोलॉजी को यूएस, चाइना और रशिया से कंपेयर करेंगे तो हम अपने आप को कमजोर पाएंगे। आप सोचिए, हम एक ऐसे देश है जो हमको लड़ाई अपने पड़ोस से लड़नी, तो हमारा पड़ोस इतने बगल में है कि अगर उसको हम ईटा भी खींच के मारे तो वहां तक पहुंच सकता है। तो कभी भी हमें वैसी डिमांड नहीं करनी चाहिए। हमारी जरूरतें अलग हैं, हमारी रिक्वायरमेंट अलग है, हमें काम करने का सब्जेक्ट अलग है, हमारे दुश्मन अलग है। हमें बहुत दूर नहीं जाना, लेकिन यूएस एक टेक्नोलॉजी को डेवलप कर रहा है और सेम टेक्नोलॉजी हमें भी चाहिए। ये एक अच्छी डिमांड नहीं है, मैं ऐसा कहता हूं। मैं इसको गलत नहीं कहता, ये अच्छी डिमांड, बिकॉज यूएस लड़ाई पूरे ग्लोब में कर रहा है, वो इवन स्पेस में भी कर रहा है। तो हमें चूज ही होना है अपने लिए, तभी हम जल्दी आएंगे और अपने काम को पूरा कर सकेंगे। तो दैट इज माई, बिकॉज मैं एक टेक्नोलॉजिस्ट के साथ एक इकोनॉमिस्ट भी हूँ, मैंने इकोनॉमिक्स में पढ़ाई की, तो मैं सब्जेक्ट को, उसके पैसे, उसके इन्वेस्ट
डिस्कनेक्ट होके नहीं।
बीच में अनकनेक्ट हो गया था। हो सकता है कि मैंने
हाँ
का एक डिप्लोमेटिक जवाब आपको दिया होगा। मैं इसके क्रेडेंशियल पे नहीं जाऊंगा, बिकॉज इट इज अ सब्जेक्ट टू स्पीक बाय आवर सम टॉप लीडर्स। सो
राइट
बट दिस इज माय आंसर।
राइट।
There's a question from Alok Mishra. How do we use reinforcement learning in autonomous ships running without pilots or drivers? Which network it is?
Yeah. Okay.
Mr.
You see,
Kataria, this question you are not audible.
Okay, I'll repeat the question. This question is from Alok Mishra. Hi, how we use reinforcement learning in autonomous ships running without pilots or drivers? I request Mr. Saxena to answer the question, and then I'll ask Dr. Lakshman to second the question.
actually, you see, in autonomous ship, the technology is already there. It's nothing very great. So the biggest challenge is not to make a ship without any crew members. Biggest challenge is to run it. Okay. Why? Because you see, ships are something which go from jurisdiction to jurisdiction. Okay. And a whole lot of different legal systems work into it. So that is one very big challenge. That how will that happen? Because whatever ships have been, as of now, there are two ships which have been worked, but those are coastal ships. They're not going anywhere in international waters. Okay. So uh, that challenge has to be done. As far as the training part is concerned, yes, there has to be a, instead of the crew member, there will be a shore operator. There will be somebody who will be operating the vessel from shore. Okay. So he or she has to have that adequate understanding of all the systems and whatever I had explained about conveying the real-time data, that has to be there. So that part is nothing great or nothing very different from what is happening. But as I said, the biggest challenge is this. You see, because on the ships, what happened, as I said, there are only 20, 21 crew members. Okay, there's nobody. I mean, defense is different. On a small naval ship, you may have 200 people. Here we have a ship which is almost 1 kilometer long and which has got only 20 people. Okay. And that those 20 are from different nationalities. There's not even a doctor on the ship. So to that extent, it becomes little complicated, especially from the legal point of view and the security point of view. Okay, the security point. The ships are, very easy targets. Very easy targets, because they have no way of defending themselves. Absolutely. I'm talking of commercial ships. There's absolutely no way of defending themselves. Okay, they can be easily taken by a simple boat. Today, the Somali pirates are so highly carrying such technical and high-end weapons. Nothing can happen. Nothing can sort of prevent them. So that's why hijacking still happens, in spite of all the modern defense mechanism, all the modern navies which are there. The US Navy, the French Navy, the Indian Navy, everything is there. But still hijacking happens. Okay. So those are the challenges. The technical part is not really a challenge. Thank you.
I think we should come to an end of this session. And before closing, I request Ms. Kamakshi Puri, AGM Project Management, Vodafone Idea, Mumbai, to please present vote of thanks. Ms. Kamakshi Puri,
Am I audible?
now you are audible.
Okay. Good afternoon, respected speakers, Dr. B.K. Saxena, Dr. Lakshman Singh, our senior IoT members, professionals, participants, and dear friends. It is both an honor and a privilege for me to deliver the vote of thanks for today's webinar. On behalf of the IoT Society of India, I would like to extend my heartfelt gratitude to our speakers and to everyone who has contributed in making this session a great success. First and foremost, I extend my gratitude to our esteemed speakers, Dr. B.K. Saxena, for sharing your expertise and providing us with a deep understanding of IoT usage in the shipping industry, for performance monitoring, for carrier tracking, and for digital twins and more. And thank you, Dr. Lakshman Singh, for enlightening us about IoT in defense avionics, predictive maintenance, and smart tracking systems. Thank you, our esteemed speakers. Your insights have been invaluable, and we truly appreciate the time and efforts you have dedicated to this session. I would also like to extend our sincere appreciation to the organizing team, technical support staff, and everyone behind the scenes who ensured the smooth coordination of the session. Your hard work and dedication is truly commendable. Special thanks to Shri Puneet Pandey, Secretary IoT Society of India Lucknow chapter, for providing the technical support in organizing this webinar. And big thanks to all of you, the participants who joined us today with such enthusiasm and engagement. Your presence and active participation has shown that the future of IoT is indeed in good hands. It is through platforms like these that we come together and shape a more secure IoT environment, ensuring that we have an interconnected future which is both innovative and secure. As we conclude, let's continue exploring the vast realm of IoT and its potential and apply these learnings to derive initiatives. We look forward to meeting again in future sessions, and I encourage everyone here to stay engaged, keep the conversation going, and continue pushing the boundaries of what's possible in the world of IoT. Let today be a reminder that we are part of something truly transformative, and together we are paving a way for a more smarter and more secure future. Thank you all. I look forward to see where the next steps in this exciting journey takes us. Thank you.
Thank you, Kamakshi. And I think with this, I declare the session closed. Thank you very much. Thank you all for joining the session. Thank you.
Thank you. Thank you, everybody. Greetings.